What if you are not a person with a past, but a momentary accident? A mind that blinked into existence a few seconds ago, complete with memories of childhood, friends, and yesterday's breakfast, despite none of it ever happening. If that sounds absurd, good. Because some versions of physics quietly suggest it might be the most likely way for a mind like yours to exist. Start with something you already know. Heat spreads out, ice melts, coffee cools, order turns into disorder. That one-way drift is called entropy, and it's why time feels like it moves forward. But physics at the microscopic level is mostly reversible. The equations don't mind if a movie runs backward. So why does your life never run backward? One answer is statistical. The universe began in an extremely low entropy state. Since then, it's been relaxing, like a tight spring unwinding. You are living in the afterglow of an improbably ordered beginning. Now here's the strange part. In a system at equilibrium, maximum entropy, random fluctuations still happen. Tiny ones are common. Big ones are rare. But give a system enough time, and even extremely rare fluctuations can occur. So imagine an unimaginably old universe. A universe that lasts not billions of years, but effectively forever. If it sits in something like heat death, thin, cold, and nearly featureless, then most of its history is boring equilibrium. Yet over that endless boredom, random fluctuations will occasionally assemble pockets of order. At first, that sounds like a hopeful story. If the universe goes on long enough, it can accidentally recreate complexity. Maybe even recreate worlds. But statistics has a cruel preference. The smaller the fluctuation, the more likely it is. And the smallest fluctuation that produces you is not an entire planet, an entire evolutionary history, and an entire cosmos full of galaxies. It's just enough particles, briefly arranged, to form a functioning brain with a convincing set of memories. A brain that thinks it has lived. If you're following the logic, you can feel the trap closing. In an eternal or extremely long-lived universe, there could be vastly more of these accidental, short-lived minds than there are minds born the slow way, inside stable planets and long histories. If that's true, then when you ask, what am I likely to be? The statistics whisper an uncomfortable answer: a statistical fluctuation. A Boltzmann brain. The idea takes its name from Ludwig Boltzmann, a 19th-century physicist who helped connect entropy with probability. Boltzmann wanted to explain why the universe looks so far from equilibrium. His tools were statistical mechanics, the idea that what you observe is often just the most probable arrangement of many moving parts. In the late 1800s, some scientists wondered if the universe might be eternal and roughly in equilibrium overall. Boltzmann suggested that maybe the universe is mostly at equilibrium, but we live in a rare low-entropy fluctuation. In that picture, your ordered cosmos is like a temporary swirl in a calm sea. At first, it feels almost poetic. Then you do the math in your head. If a fluctuation can produce an entire observable universe, it can also produce something much smaller that still has observer status. And because small fluctuations are exponentially more probable than enormous ones, you get a prediction that sounds like a practical joke. The typical observer is not someone embedded in a vast, coherent universe. The typical observer is a lonely brain, popping into existence in the dark, hallucinating a sky it never actually sees. And it gets worse. Your memories become suspicious, because a Boltzmann brain doesn't need a real past. It only needs the physical pattern that represents a past, the feeling of continuity, the internal evidence, the I remember therefore it happened. You might think, fine, but my world is consistent, science works, I can test things, I can predict eclipses, I can build computers, surely that rules out being a random brain. Not so fast. A sufficiently detailed fluctuation could include a brain with a coherent set of memories of doing science, reading textbooks, and checking experiments. It could even include the feeling of having checked yesterday. The evidence could simply be part of the fluctuation. Now the mystery expands beyond psychology and into cosmology, because this isn't just about a creepy thought experiment. It's a test for our theories of the universe. If your best theory predicts that most observers are Boltzmann brains, then that theory starts to eat its own credibility. It suggests you should distrust your reasoning process, because your reasoning is probably the random product of chaos. This is where fields collide. Statistical mechanics, cosmology, and the arrow of time all meet in the same uncomfortable room. Modern cosmology adds fuel. Some models of the universe involve something like de Sitter space, a universe dominated by dark energy, expanding forever with an apparent horizon and a temperature associated with it. In such a setting, equilibrium-like conditions can exist, and fluctuations can be discussed with real equations, not just philosophy. Inflation complicates it further. Inflationary models can generate enormous volumes of space, potentially endlessly, through processes like eternal inflation in some scenarios. If space keeps being produced, then all kinds of rare events happen somewhere, sometime. That can create a measure problem. How do you compare infinities? How do you say what is typical when there might be infinite normal observers and infinite freak observers? And then there's the anthropic angle. You only ever find yourself in a place compatible with your existence. That's true, but too weak. Boltzmann brains are compatible with existence too, so anthropic reasoning alone doesn't save you. It might even make the paradox sharper. If being an observer is the only condition, then the easiest observer to make might dominate the statistics. By now, the story is no longer, maybe you're fake. It's maybe our universe model is broken unless it avoids producing mostly fake observers. Physicists have taken this seriously. Sean Carroll has written about Boltzmann brains as a problem for cosmological models and for how we define typicality. Andrei Linde, a key figure in inflationary theory, has discussed related issues in eternal inflation and probabilities. Don Page has analyzed Boltzmann brain production in cosmological settings and argued that certain universe lifetimes or vacuum properties matter for whether Boltzmann brains dominate. These aren't fringe people. This is mainstream physics bumping into a philosophical landmine. The paradox also connects to the work of Roger Penrose, who emphasized how extraordinarily low the universe's initial entropy seems to be. Penrose's point is Boltzmann brains are real. It's that the arrow of time and the specialness of the beginning demand explanation. Without it, statistical arguments start to do unsettling things. Even the concept of typical observer is debated. In cosmology, your conclusions can depend on how you count observers, how you regulate infinities, and what you assume about the distribution of conscious experiences. Those choices aren't always dictated by data. Sometimes they're dictated by the desire to avoid nonsense. And now, around this point, the twist arrives. Most experts do not think you are a Boltzmann brain. Not because it's emotionally unpleasant, but because the best supported picture of our universe doesn't look like the kind of equilibrium bath Boltzmann originally imagined. The standard cosmological model says the universe evolved from a hot, dense early state. We have evidence for that. The expansion of space observed through galaxy redshifts, the cosmic microwave background radiation, and the abundance of light elements predicted by Big Bang nucleosynthesis. These aren't vague hints. They're measurements that fit together tightly. In that story, you are not a rare fluctuation in an eternal equilibrium. You are part of a long, structured history where entropy has been increasing for 13.8 billion years. Your brain is expensive, but it was built by a planet powered by a star, which was made by generations of stars before it. The universe is not sitting around waiting for random brains to appear. It is busy running down from an initial low-entropy condition. So why not declare victory and move on? Because the Boltzmann brain problem doesn't disappear. It retreats to the edges of the theory, the far future, the deep assumptions, the what happens after everything else. If dark energy really acts like a cosmological constant, expansion could continue indefinitely. In a de Sitter-like future, you can ask again whether thermal or quantum fluctuations could eventually produce Boltzmann brains. Over unimaginably long times, even absurdly rare events might happen. Then the question becomes whether normal observers like you are still the dominant kind, or whether freak observers take over in the limit. Some physicists argue that realistic decay of the vacuum could prevent this. If our vacuum state is metastable and decays on a timescale shorter than the time it would take to generate overwhelming numbers of Boltzmann brains, then the paradox is avoided. But we don't know the vacuum's lifetime. We don't even know if dark energy is exactly constant. Observations currently allow it to be close to constant, but not perfectly pinned down. Other approaches say the counting itself is wrong. The measure problem, in eternal inflation, might be resolved in a way that doesn't reward Boltzmann brains. Or maybe the correct definition of an observer requires not just a brain state, but a robust connection to an external environment, stable enough to support reliable knowledge. That sounds plausible. It also sounds like moving the goalposts, because we still don't have a universally accepted physical theory of consciousness or observation. And then there's the awkward meta point. You are using your present observations to judge which observers are typical. But typical is a statistical concept that depends on the underlying theory, and the theory is being judged partly on whether it makes your observations typical. It's a loop. Not necessarily a vicious one, but a loop you can't ignore. So you end up in a gray zone. Boltzmann brains are not a prediction you should lose sleep over. They are more like a stress test. A warning light on the dashboard of cosmology. If a model makes the universe so old, so empty, and so dominated by equilibrium that accidental minds outnumber evolved minds, then something is off, either with the model or with how you're extracting probabilities from it. But you also can't fully dismiss the question, because it points at real gaps. Why the early universe had such low entropy, what dark energy truly is, and how to handle infinities without breaking the meaning of likely. And that brings you back to yourself. Right now, you feel continuous. You feel embedded in a world with rules. You can test those rules and they keep working. That is powerful evidence that your experiences are connected to a stable external reality. Yet the paradox reminds you that evidence is always interpreted through a mind, and minds are physical things, subject to the same statistical laws as everything else. Maybe the deepest lesson isn't that you're probably a fluctuating brain. It's that your confidence in reality is not just built on facts, but on the universe being the kind of place where facts can be trusted. And if the cosmos ever stops being that kind of place, the first thing to dissolve won't be the stars. It will be certainty. Because in the end, the scariest part of the Boltzmann brain isn't the idea that you could be alone in the dark. It's the idea that the difference between a real history and a perfectly convincing fake might be written in probabilities so large, and times so long, that even the universe can't tell you which one you are.